Good morning, everybody, and thanks for joining us for Tracing Bare Metal with OpenTelemetry. We went ahead and generated a trace visualization of our talk outline. The span times are approximate, so don't be too strict with us. But first, we're going to share a bit about how things were at Equinix Metal before we had tracing. And then we're going to talk a bit about initially adopting OpenTelemetry, some of the snags we ran into, and the lessons we learned. After that, we'll talk about onboarding and enablement work that our SRE team has been doing for our engineers, plus some recent wins. And finally, we're going to trace through the bare metal provisioning process.
So in the bad old days, when I started at Equinix Metal about 18 months ago, there was kind of a lot of stuff you've probably seen before in your work. We had long incidents. One of the first things I did, right, being an incident nerd, was start lurking incidents, going to incident reviews. And what I saw right away was these incidents would stretch out for hours. We'd get inconclusive findings, like you'd get to the end and we'd restart everything, and then the service would come back to life and we would move on. But for me, it was very unsatisfying to not find an answer. We saw this manifest in the engineering teams as learned helplessness, which is kind of like when you encounter an engineering team where they're kind of like, oh, I can't do that. I can't deploy today because I don't feel safe doing it. So all those kinds of things that kind of slow down the pace of engineering. We had incidents that rhymed. You know, they had kind of similar onsets, similar kind of symptoms, but they weren't clear enough for us to get to those conclusions. And again, it made the whole process very frustrating. And we had team siloization, which is kind of like that helplessness where teams were like, well, you know, that's really those guys' problem. It's not my problem. And then you go to the other team, they'd be like, well, it's not my problem. It's those guys' problem. And we had this kind of stalemate going on. And that kind of reflected with low autonomy as well, where we didn't see engineers kind of jumping into things the way that we want them to. So I was hired in to do tracing, and the goal was to trace all the things. We needed observability badly, that was really clear. And we decided right at the beginning to go all in on OpenTelemetry, even before the spec was 1.0.
So this was around the end of 2020. And also shout out to Fred at Honeycomb for inspiring this diagram with our very valued customer at the top. It took some months for tracing to really gain traction. And it wasn't until about May 2021 that the team was ready to turn on OTel tracing in our central API service. And what that meant was we had an environment variable that wrapped around our initialization code to enable or disable the OpenTelemetry's recording mode. So this whole time people were instrumenting code and that code was in production, we just weren't sending trace data. And so in May 2021, we were finally ready to turn on tracing, and it was relatively quick thanks to this environment variable. So we turned it on.
Everything just kind of blew up. It was really crazy. Like we started seeing things like double render errors in Rails. We saw worker jobs kind of just exploding all over the place. Sometimes they would run really long. Sometimes they would crash and go into crash backoff loop in Kubernetes. Again, we were in that incident mode where it was really hard to get conclusions because we didn't have the observability data in this kind of catch-22. We're trying to get the observability in there, but getting stuck because of problems that were exacerbated by the observability itself.
So this wasn't a great first impression for OpenTelemetry. And this happened multiple times. The team would enable OTel, failures would start increasing, disable OTel, or we would enable and disable specific integrations. And toward the end of the year, we were adding more and more instrumentation across different services as well as in the API.
Rolling into early December, because we added all this new instrumentation to the code, when we turned it on in early December, you can kind of see here on the left, we didn't show the errors. Is that fun?
No, it's not.
We didn't show the errors here because it's kind of embarrassing. But we were coming up on, Equinix did a company shutdown at the end of the year for the whole company, and a bunch of people wanted to take the week before that off. And we were all feeling really crispy, and so I made the call to say, leave OpenTelemetry off through the end of the year, which is kind of like, really, as an SRE, it kind of just hits right in the gut,
So we had a couple weeks off. Here you can see it's like a 3-week gap in our API data. And when we came back, Amy was just ready to dive right in.
Yeah, I came back to January kind of angry. And I over the break, been thinking about this, like, what is the problem? And I tried a couple of things right away, right when I got back on that Tuesday when we all came back from break. And it was like, look at the Rails worker code and see if maybe I could add some locking in there and bring some sanity to all this. But it turned out I did a grep and found this threading code that somebody had added. And in Ruby on Rails, your unit of concurrency is a worker job. It's not a thread. And so most of the modules didn't understand that there was threading happening. And so we had just all kinds of chaos ensue. So I just removed that code and serialized all of it, all the way through the code base. And then we turned it back on, and it's stayed on ever since. And the QR code there, by the way, was the blog post I wrote about that. So
yeah, if you'd like
we'll
to read
later.
Yeah, in more detail. It's a really good post. So I joined Equinix Metal about 6 months ago in September of 2021. And by then, Amy had already laid a lot of the groundwork, adding tracing to different services outside of our central API service, especially our provisioning stack, and even grabbing hardware data. And this was really important because the big initial goal for tracing was end-to-end tracing on our bare metal provisioning process. That's our bread and butter at Equinix Metal. But Amy couldn't do all this work by herself. She needed a team so that we could scale the technical work. Plus, there was all this socio-technical work to do, running incidents and enabling people. And so one person alone can't create a culture, an engineering culture of production ownership.
So I'm not going to go into this, but this is kind of the SRE model that I've been working on for a while. And so I wrote a one-pager about this, taking these kind of 3 elements of SRE that are basically big feedback loops. Observability being the one that we're here to talk about. We have incidents. We'll talk about that again in a minute in the way that that interacts with observability. And then kind of SLOs is a broad engineering feedback loop.
So when I started, one of my primary goals was observability onboarding. And luckily, I just spent a year doing exactly that kind of work as a developer advocate at Honeycomb. And so while our engineers had a lot of experience debugging with logs and metrics, almost nobody at Metal had ever used tracing. And so that was a knowledge gap that I could help fill. Plus, in SRE, we didn't want to do all this work in setting up tracing and generating all this data, only for people to never actually go and look at it, right? We want to set up tracing so that people can get value out of it.
So this is the first part of technical stuff. If you're going to start on doing OpenTelemetry in your stacks, the first thing that I did, and it turned out to really well, was to add the plumbing to all the code. And this means going and adding the OpenTelemetry initialization code to all of your services, adding your auto instrumentation to them in the next step, and then worrying about the custom instrumentation later, and we'll come back to that. So you probably want an OpenTelemetry collector. Now, this is a topic of a whole talk by itself. The QR code there is a link to Shelby's post about the collector. And it's basically a proxy for sending your traces out and be able to funnel them through, say, as a proxy if you have NAP limitations and things like that, or just for resiliency against internet failures. The next thing is tracing initializers. When we were doing our initial project, there wasn't a great one for Go. There was one that Lightstep had. It wasn't quite ready for general use. I think it is now, so check that one out. But we wrote our own for this. It's a pretty simple little one out there. We'll link it at the end. And then lastly, you almost certainly want to make sure that your propagation is working between services. What I mean by that is there's a set of headers that are defined by W3C as a specification, and OpenTelemetry borrows from these. There's also a couple other standards that people use, like B3 format. But this is the one we're using, which is because it's kind of simple. So what we have here is the 3 main headers that you'll see when you're dealing with OpenTelemetry propagation. Trace parent being the main one. This is the one that we plumb through all of our services. And that's the one that communicates, so in the blue is like a version ID. The red there is your trace ID. So sometimes when you see these in logs and things, you actually want to grab that red part to search in your telemetry tool. The next part is the span ID from the originating service. That'll become the parent span of the child service. And the last part is your sampling flags. The last thing, so these are common headers. The trace state is mainly vendor stuff. Most of us don't have to implement it. I didn't implement it at all in our services. And then baggage is this kind of out-of-band signaling system where you put arbitrary key value pairs in there. And you can put stuff like a user ID that you want to propagate through the services, even though maybe downstream services don't know about that concept. You can stuff that in baggage and actually tunnel it through. The downside being is that if you have this arbitrary key value store that's out of band, making sure your engineers don't abuse it. Because engineers love to pick up out-of-band signaling and stuff, all kinds of crap in there. Last thing I'll say is sometimes you have to do in-band signaling. So there was one application, our SDN system, had a worker system where it would write to a database, and then on the other side, workers would pick it up out of the database. And there wasn't anywhere to put headers. So all I did is I added a column to the database that was the trace parent, and just wrote it in there so that the job could pick it up and then restore the state propagation. So sometimes that's necessary just to get the job done.
So the next thing to set up is your auto instrumentation. And what's great about OpenTelemetry is you get a lot out of the box with the SDKs. You get HTTP requests and gRPC requests. It differentiates between client and server calls. So that's like the root span here is a server span, and then the HTTP post and get are client spans. And so what's cool about this is with auto instrumentation, you start seeing the shape of your system, and this helps improve people's mental models. And so let's talk about mental models for a second, because it turns out they're kind of important. We already mentioned the lack of autonomy and some learned helplessness among our engineers. In incidents, there would be like one or two senior people who would sort of jump in and perform heroics and resolve everything single-handedly. Amy, you've talked about this before.
Yeah, so for a lot of my career, really about 5-10 years in, I kept getting the same question. I do think probably some of you do, right? Is you go look at all the telemetry that you have and maybe glance at a few dashboards, and you got this maybe 15-20 minutes. And you come back and go like, I think you need to restart the database and change this flag and turn it back on. And people are always like, whoa, how did you do that? And I'd say like, well, it's pattern matching. And if you spend countless hours staring at logs and graphs and poking around in /proc over the years, you'll pick up this ability.
Right, but I don't have years and years and years to stare at logs and play catch up trying to learn all this stuff. I'm trying to solve problems today. So what I realize about what these experienced folks are doing is that they're mentally tracing through the system. But with OTel, we can just have the code trace itself. We can store that trace data outside of people's heads, render it in a friendly visualization, maybe make it linkable, share it in Slack, and start talking about it. And then, our senior folks can come in and start cross-pollinating all this valuable knowledge they've earned over the years. And then, everyone else can start, becoming more involved, not just in incident response, but also, proactively improving the system. And this is how we combat that lack of autonomy and the learned helplessness.
We threw this one in here because we wanted to say a little bit about the testing situation where we are is much better than it was when we started. But we're all kind of chasing the tail as SREs, getting more testing in the system. So we have this thing where you probably all heard this before, right? Is there's no place like production for actually shaking the bugs out of your code. And there's some folks out there that talk about test in production. But what we wanted to really drive home that you take home with you is that these fast feedback loops that tracing and observability, kind of modern observability give you are what makes that safe to do. Without that fast feedback loop, it's actually really dangerous.
So we already get all this valuable stuff with just auto instrumentation, but the real money of observability comes from custom instrumentation. You want to grab all of your critical business domain data. At Metal, for us, that's instances, hardware, operating systems, plus things like users and projects and organizations and plans. And we can't predict, and this is something we saw in incidents all the time, we can't predict what intersection of a data center and a hardware type and an operating system and a billing plan is going to run into some emergent failure mode. So with tracing, we can just capture all of those things as raw data, and then later at query time, we can just figure out the intersections of that. The caveat is that you want to make sure your tools support capturing lots of attributes on your spans and capturing attributes that have lots of possible values, high cardinality attributes. But once you're confident about that, please go forth and instrument. So Amy, how do we know we're on the right track? We're doing all this work.
So there's some behaviors we start to see emerge from the team, right? I don't care about what the tech is doing half the time, right? I'm watching what the engineers are doing, how they're talking in the Slack channels, how they're communicating with each other. And what we saw was some really cool things start to happen, even just in the last few months. where we have developers come to us and be like, hey, how do we get into Honeycomb? How do we add OpenTelemetry to our services? And every time that comes in, both Shelby and I do a little like, ee!
Yeah, and people would ask for pairing time, which I love doing this because they usually know of part of the system. They have like a service that they work on or several. And so we'll jump on a Zoom and I'll have them pull up a trace from their part of the system and I'll have them explain it to me. And they've never looked at this kind of trace before, maybe none of our trace data, but like you can watch in real time the gears turning and it clicks because they know the service and they know the code. And so they're just like, mapping what they know to what they see in the trace. And they'll start to see like, oh, I didn't realize that fires, in this timing and like the order here. And I wonder if that's normal and stuff. And so it's just very, very cool to like just watch it in real time.
The other thing we really like seeing is when people go and write a PR, and sometimes they'll even merge it, and then we'll see it like show up in the traces. And that's another one of those little moments. It's not quite the E, but like it's like we see it, and we're like, ooh, that's cool.
Yeah.
And these are like the emergent things we're looking for from the teams. And then finally, we want people to be sharing these. The big feedback cycle where we tell if this is all working is in incidents. When we're driving through an incident and we see people posting links to Honeycomb or whatever your tracing vendor is, right? That's what you're looking for, is that behavior where people are starting to use the tool under pressure.
Mm-hmm. And like if there's an incident going on and people aren't as familiar with the trace data yet, they'll be sharing links to dashboards and to logs. And so us in SRE will go and query for the corresponding trace data and we'll share it back into the incident channel. And this is really important because after all these fits and starts and snags in the beginning, we want to build confidence in our trace data, both for the overall engineering team and also for ourselves. Like, is this new lens into production? Does it agree with our existing lenses? And so that's been really, really valuable.
So we've talked about what's hard. Let's talk a little bit about the fun side of this.
So Amy talked about back in January, finally resolving those threading issues, the workers just pulling out all that threading code and serializing it. A couple weeks later, leadership came to several of us in engineering and asked us to set aside our sprint work for a couple weeks to focus on these long-running performance issues in the customer portal that had kind of come to a head and really needed to be addressed.
So one of the things we saw, jumping back a little bit, when we first turned tracing on, we turned on everything. And one of the things that was included in that was auto tracing for active record. And immediately, one of the first things that happened was we saw the system slow down and start chunking. And then we saw the OpenTelemetry collector kind of catching fire and dumping lots of stuff in the logs. And what it turned out to be is when I'm going through the traces, I found one that had 23,000 spans in it. And it was the Rails N+1 problem. But at that time, we really couldn't do anything about it. And so this is kind of like us showing, this is an old issue in the stack that goes back to the beginning of the startup that became Metal. And and so now we're in this case, and it was the opportunity to finally go let's attack this N+1 problem. Mm-hmm.
But of course, we turned off that active record tracing very, very early on because generating traces with thousands and thousands of spans puts a lot of load on the API. So we needed a way to minimize the blast radius while still capturing a lot of this granular database query data. And so maybe it's not the ideal feature flag use case, but we set up a launch directly feature flag to wrap around our active record tracing initializer. And then we could enable it conditionally by user ID. So it wasn't even a subset of traffic. We just enabled it for two of us working on this performance work. And here's what we saw. It was really important to validate that these optimizations were actually working. And because these are scale issues, we needed to test it in production, right? And so these first two columns here are from the same day. One is our baseline production image, just what was already running. And the second one is a PR image from John, one of our principal engineers, who dove into this, started making optimizations. And so we went and canaried that in our API internal deployment in our API cluster. And then we can compare a single request in the baseline, how many queries are we running, compared to when John started going in and detangling some of these N+1 queries, and we saw an immediate improvement. And then because like he could sort of iterate on this very quickly, within a couple weeks we started reaching like diminishing returns. But just, yeah, it was very, very cool. So each of these is one request. They're sort of exemplars of the before and after.
So we showed you the count on that previous slide instead of the raw performance because something happened kind of under the covers. We started pulling those traces out and we posted them in a channel so everybody could see them. And our DBA kind of went quiet for a little while. And we didn't really notice, right? You know, it's always like with kids. It's when they get quiet that you're supposed to worry. When your DBA gets quiet, they're always kind of quiet, you know? And so one day we're looking at the traces and we see this happen. But we didn't do it. We didn't know where it came from. And so we're like, post the channel, like, hey, what did you push the new thing? Did you push the new thing? And then DBA pops like, hey, I was looking through that trace and I noticed a few things, so I went and I tuned Postgres a little bit, and then like, I think it helped a little. And this is what happened.
And so thanks to Mark, our DBA, we hit our quarter P95 performance goal in a day. Just a couple hours of like going through cleaning up indexes and stuff. It was very cool.
But he was really clear with us that he couldn't see those queries because they weren't slow, because our slow query log was set to 50 milliseconds. It wouldn't log the query unless it was slower than that. But most of these were running in 1-2 milliseconds. So there was no other way to get visibility until we added the application visibility. Mm-hmm.
Turns out even if something only takes 1 millisecond, if you do it 23,000 times in a request, it slows things down a little bit. So the IP's endpoint was probably the worst offender. That was what our original sort of smoking gun trace was from last summer. And so this is what we saw. We're comparing time over time from the end of January to the end of February, just shoo, dropping all like.
We took the y-axis off here because it's a little bit embarrassing because we're now at like a somewhat reasonable latency, but there's still a lot of work to do. So we basically cut the latency in half or a little bit better.
So beyond all of these technical wins, we also started seeing some socio-technical wins over the last few months, especially because this performance work, people were using the portal. It's like, wow, it's so much faster now, and we got some shout outs and like all hands and stuff. And so we started getting a lot of visibility around tracing. And then John doing all of this iteration on the optimization work, people are like now aware like, oh, canarying, it's not that hard, especially when you have like a nice tight feedback loop. So now more people are canarying because they've seen it done.
The other thing we saw that I thought was really cool is that one morning an engineer pings our team is like, hey, I kind of want to run like a SEP3 incident and try an experiment. It's like, an experiment, you say? He's like, yeah, my hypothesis. I'm like, wait, you got a hypothesis? I was so excited. And he was like, yeah, I think if I change the setting in production in one region, I have, that it'll exhibit this behavior, and if I'm wrong, it'll exhibit this other behavior. So we're like, fire that incident up. We'll be there. We'll be helping you watch. We ran the experiment. The experiment failed, but ultimately, like, it was the success for us because seeing people like run their own chaos experiments, we didn't have to do anything. Like, they just started doing it.
Yeah, and then also just again because we were getting shout outs and stuff about how valuable this tracing work was for our performance stuff. Now teams that are building out new services are coming to us and being like, hey, can you help us set up OTel on our new service? And so we ended up having like enablement sessions 2 days in a row, which was really, really cool. And so and the thing about this like observability onboarding work is it's a lot less of like these formal like workshops or presentations or anything. I've done two. One was like a relatively informal lunch and learn. It was like, hey, look at our trace data so far. And then another one was like a specific team was like, hey, can you show us, the trace data specific to our service? But it's mostly been just like ad hoc conversations in Slack or jumping on Zoom and screen sharing, having that person drive and just helping people like learn the tool and learn the data. So that's enough of all of that. You all came here to hear about tracing bare metal, right?
So what this is showing you here is this is kind of our full metal trace. We actually had to break this up because it's a really long trace. Because this is when you come to our API and say, hey, give me a server. It's kind of like with the AWS and other cloud APIs, except when you ask us for a server, we give you a real server. You get the whole thing. So there's a lot of different things from firing up a VM, right? You got a PXE boot, you got to install an operating system, all this stuff. And so under that kind of folded, highlighted trace is the 507 spans that come in through that process today, and we're not even done yet. So inside of this is, whether you hit the Rails endpoint, right, it goes and fires off a background job, and then this provision device job kind of runs through the workflow of installing a server. And that's kind of what you see here is it's, turning the power off on the server, turning the power on, setting the boot device to PXE, all of these things. And one of the cool things about this when we turn it on is, again, people just didn't understand what that workflow looked like until we showed it to them in a trace, because the Rails code was kind of all spaghettied up. We've since fixed that, but it was really nice to see it, and then it made the de-spaghettiing a lot easier.
So after that last part of the trace where we call out to the PB&J service, which stands for Power, Boot, and Junk, I think, then we call it to Narwhal, which is our software networking service, and that sends some switch configuration data directly to the hardware. So we have actually some custom spans here for our specific switch hardware to capture that data. And then Narwhal also handles the ACLs on the switch. And what it does, API, makes these requests to Narwhal. And then for the port, it's like, OK, is it done yet? And then for the ACL, it's like, is it done yet? And it does that over and over.
Hey, have you ever been on a car trip with kids? And after the first 10 minutes, like,
are we there yet?
Done yet?
Are we there yet?
This is what it looks like as a trace. This is like the worker going and pinging and hitting the endpoint, being like, is it done? Is it done? Is it done?
Mm-hmm. And it's like this sort of repeated polling behavior. You might ask, is this desirable? Maybe we should fix it. Well, what's the senior engineer answer? It depends, right? Today it's working, we're provisioning hardware. It's not the biggest fire. Maybe we'll want to change this in the future, but this is our status quo. So once ports and ACLs have been configured, API, here's back from Narwhal. Cool, they're done. And then it asks Narwhal, can you configure some port ACLs? So then it does another round of polling. That I sort of skipped that part. And then we get to the end of this particular trace. And there's more to provisioning. There's stuff we haven't even, traced yet, instrumented yet to capture. But we get to the end, and I just wanted to point out the asynchronous nature here, where at the bottom, all of this stuff is API returning that 200 OK back to the user from that original, please make me a server request. But the actual provision stuff happens way later. So if you've never seen an async trace visualization before, might be a little confusing, but now you've seen it, so you're good.
We're going to go real fast through this because we got to get to our recap, which I think is next.
Yes.
And so this is kind of the one thing I wanted to say here is there's a little bit of sample code for custom attributes there. That's not what I'm here to talk about. We have this part where the DHCP request comes in. And so this is where the DAG in the trace breaks. So the OpenTelemetry spec says that a trace should be a directed acyclic graph of spans, right? And so sometimes you have in a service where you're coming on down your DAG, and then you have something happen over on another that originates from another part of your system, and then kind of comes up and meets up with that process. And when that happens, there's a functionality called OpenTelemetry called links. We're just starting to deploy this code now to do that, but it seems to work pretty well. It'll show up as a little, like Honeycomb, it shows up as a little link you can click. We're bothering to make that nicer. And I think all of the other telemetry vendors support it pretty well right now.
Mm-hmm. And basically, I wanted to include this as an example of here's your sort of business domain custom instrumentation, and also the purple in the code looked really pretty with the purple in the trace. So, cool.
So to wrap up, an SRE team in observability, right? Our job isn't to go, now we had to do some of this work where I go out and help and write PRs for the teams to get them started. But our real goal has always been to get into this mode of enablement where we're helping teams kind of self-support themselves.
Mm-hmm. It takes work to onboard your engineers, and you want them to really embrace tracing as one of the tools in your tool belt. So don't underestimate the effort in that. We also started seeing oh, sorry.
Yeah. Consular adoption is this funny thing, right? You don't just start it and it takes off. It's this it has this circular dependency that we got to work through, and it's really just hard work. Success kind of relies on adoption, which builds on success, and then you kind of can build this stuff up over time, and it gets away from you.
Mm-hmm. So we really started seeing the ball get rolling once we had some successes we could share. And now that we have this shared view into production, that's helping everyone improve our mental models. And so observability is the enemy of that like final boss of learned helplessness. We're talking about, you know, monsters in this conference. So the swamp monster of learned helplessness.
And who watches the watchers, right? So for your observability program, the feedback cycle that tells you if it's working is your incident process. And so if you have a strong incident process, you can use that to see, is my observability working? Are people using it? And you feed that back into your observability program to make improvements and address teams and things. Mm-hmm.
It's feedback loops all the way down, and our job in SRE isn't just to like create these feedback loops, but it's also to make them accessible not just to our engineers, but to the greater organization, so that we're all on the same page, we're all working towards the same goals, and we all agree on like what needs improvement. And one example of that is with SLOs, which we've been like starting to work on.
And we're just getting started on that, but you know, just going from feedback loops, that's the kind of the next big one we're working on right now. And what we found is now that we have this rich tracing data available to us, the SLO problem got a lot easier to solve because we can target to traces instead of to like trying to pull stuff out of aggregated metrics and things.
Mm-hmm. When our trace data reflects the customer experience, it's a lot easier to write customer-centric SLOs.
And with that,
thank you so much.
Thank you.